Good afternoon, Professor Dabholkar. We are very honored to have you in this first issue of our newly launched magazine called Trends in Physics. Let me take these moments just to introduce this magazine. This magazine will feature articles written in Arabic language explaining in simple terms advanced research. This magazine is published by the Arab Physical Society, which was founded last year by a team of Arab physicists aiming to spread and promote physics knowledge, education, and research in the Arab world. So I, Nidal Shamoun, and with me, Rand Alfar, from the editorial team of the magazine, we are very happy to meet you, Professor.
Thank you. It's a pleasure to meet you. Okay, now we can go to the interview if you want.
Okay, so let me first start, Professor. Could you please give us a brief overview of your personal journey in theoretical physics and how you got to be the head of the International Center for Theoretical Physics, ICTP? Where have you done your undergraduate, graduate studies, and what was your field of interest?
Okay, so I come from India. I did my master's in physics from the Indian Institute of Technology in Kanpur, which is one of the leading national institutes in India in physics. And then I went to Princeton University for my PhD. My graduate supervisor was Professor Jeffrey Harvey, a well-known string theorist. And I did my PhD in string theory. And then I continued to work in the US for many years. I was at Rutgers, at Harvard, at Caltech. And then I was very keen to return to India it's a little bit like Salam, who wanted to go back to Pakistan for personal reasons. And so I was then a professor at the Tata Institute of Fundamental Research in Mumbai for several years in theoretical physics. And then I moved I was in Paris for some time. I have been at other places like CERN and Stanford. And then about 10 years ago, I moved to ICTP. And for the last 4 years, I have been the director. And my areas of research, I would say, are not far from, in a way, the work that for which Salam got the Nobel Prize, together with Weinberg and Glashow, was a kind of a milestone in this search that theoretical physicists have been engaged in for unifying all forces or unification, and also to understand how to bring together. One of the aspects of this search is the search to find a unified framework to describe general theory of relativity of Einstein in a consistent manner with quantum mechanics. And that's where string theory actually plays a very important role. It's one of the most promising routes towards achieving this goal. And unification of all interactions somehow seems to follow quite naturally in this framework. So it's really an exciting field of research, and I'm happy that there is a kind of a continuity with what Salam was doing.
Yeah, great. And science-wise, Dr. Dabholkar, what drew you as a young student aiming to major in theoretical physics to, quantum black holes and string theory? And also administration-wise, did promoting Absalam vision play the major role in you seeking to become the ICTP director?
Well, I think you're also doing physics, so you know that I think intellectually physics is very exciting. I mean, you learn when in school all these wonderful things about relativity and quantum mechanics, and it's always fascinating to a young person who is interested in, if you're reasonably good at physics or mathematics, it's really an exciting frontier of human knowledge. And the more part of it is a little bit of a romantic thing, you don't really make a completely rational decision, that it's something exciting, you want to do it. And you sometimes don't even know whether you're good at it, how you will do in it. But that's part of the attraction of physics, the intellectual depth of physics, theoretical physics. So that certainly was something that drew me to physics. I would say that also, I mean, Salam is an inspiration for his work that he did in physics, of course, for many of us. I think his electroweak unification is a very important milestone. But personally, for me, I visited Ictp also when I was a student in Princeton, or just after I had graduated. And I actually met Salam briefly. He was not in the best of health. And I think he was also an inspiration for me coming from India. His mission and vision and his real commitment to global science is something that I identify very much with. It's really close to my heart. I really think that science is a very important determinant of economic development in any country. And it also a very important force for international cooperation and understanding. And because of that, the mission of Ictp was also something that was close to my heart. So it was when I had the opportunity, when I was approached to consider this possibility of being the director, it was a double two ways. I felt I was connected. I mean, like Salam came from a small village in Pakistan, and he went back to Pakistan, and he could not continue his science. He felt that he had to make this choice between his country and his science. And the Ictp was created so that it becomes an international hub for science, where scientists from all over the world can come and go back to their home country and continue doing their research. When I returned to India, I had similar motivations. I mean, I also grew up in a small village in India, so I can sort of identify with Salam's background. And I wanted to go back to India. But of course, India, when I went back in the 21st century, is very different from Pakistan in the 1960s. We have some very excellent, theoretical physics institutes. So I could actually go back without really sacrificing my science. But the mission of Ictp, I believe, remains important even today.
So in this regard, Professor, could you give our readers in the Arab world an overview of the Ictp mission and the program of activities it undergoes in order to realize this mission?
Yeah, so Ictp is I would say it's really a unique institution, one of its kind. And I don't know, in fact, any other institution which has this very important role. We are a UN organization. We are an international organization. We are governed by a tripartite agreement between the International Atomic Energy Agency, the Italian government, and UNESCO. And we are a Category 1 center of UNESCO. So that gives us a certain neutrality of platform, which is very important. For example, even during the Iron Curtain days, Ictp was a place where scientists from the East and the West could come together. And even today, Ictp is a place where scientists from the global South and the global North, or East and the West, or countries which may be traditionally not politically on good terms with each other. And at the scientific level, the understanding and collaboration continues when we have scientists from India and Pakistan and Iran and United States and Israel and Palestine and Gaza. We have students currently from Syria. So Ictp's or Ukraine or Russia, Ictp's mission is that science should be a force for bringing people together. And this role is very important in the current global situation. But this is one aspect of Ictp's mission, international cooperation through science. But even before that, the primary mission of Ictp is excellence in science and capacity building in science, I mean, inclusion in science, that to make advanced science globally available to young scientists or senior scientists, overcoming the barriers of gender, ethnicity, geography, or which puts many hurdles. I mean, if you're very far away, from the center of science, then your ability to do frontline research is limited. And so ICTP gives scientists from around the world this opportunity to come here, spend 1 month, 2 weeks, 6 months, 1 year, 2 years, and really interact with the best people in their field from around the world. We have something like 6,000 scientists visiting us from all over the world every year. About 2/3 are from developing countries. About 1/3 are women. And the scientists coming from the developing countries are fully funded by ICTP. So it's a really wonderful mission. And at the same time, we emphasize excellence. I mean, the work done at ICTP has contributed to many important breakthroughs in physics and mathematics and so on, and climate science. 5 Nobel Prizes it has contributed to the work done here at ICTP. So this threefold mission, excellence, inclusion, and international cooperation, is what makes ICTP very unique.
So, in your opinion, what are the most significant issues confronting Arab scientists and researchers in theoretical physics? And how can ICTP address and help overcome these challenges?
I think one of the questions that Salam wanted to address in his time in Pakistan was the intellectual isolation of scientists. You know, that you go back to your home country, you want to be there, you are working in a university, but you may not have the experts or colleagues working in the field that you are interested in. And that leads to a feeling of intellectual isolation. And this is what, to end that feeling of intellectual isolation or scientific isolation, is one of the primary missions of ICTP. And I think that remains valid even today. Even in a country like India, which now has its own very strong scientific community, many scientists, it's actually geographically very diverse and not so uniform. So it's very useful, it's refreshing for a scientist also from somebody from India, which is in a much better place in terms of scientific community now than it was 70 years ago, to come to ICTP, really talk to the best people in the world, have this interaction. And I think this problem remains very acutely true in the Arab world, I would say. I mean, many Arab countries are now economically well off, but I think they are still scientifically isolated. And some Arab countries are also have economic and other also political problems. So it makes it difficult for scientists to pursue their science, and ICTP makes that opportunity available.
Okay, so we here in the Arab Physical Society are carrying out a program of activities ranging from summer schools, seminars to conferences. Do you see parallels where ICTP can help the Arab Physical Society in its mission? Moreover, we decided to launch this Arab Physical Society magazine, believing it would help in the dissemination of knowledge. So any advice you give us for the magazine? And is there a parallel magazine for the ICTP, or you think social media sites are enough?
So first of all, ICTP would be very happy to collaborate with the Arab Physical Society to organize scientific activities in the Arab world, to help them to get the top people to come to those conferences. This is definitely part of the mission of ICTP, or to make it possible. We have several programs. We organize about 60 major international conferences at our Trieste campus, but we also support many activities around the world at a small, relatively moderate budget. Then we also have a program called the Training and Research in Italian Laboratories. So even though we are a theoretical physics institute, let's say somebody is interested in synchrotron facility. We have the national synchrotron facility of Italy, which is Elettra, is right in Trieste. And scientists come through ICTP to attend conferences on that subject, or to actually get time on the beamline in Elettra. We have sandwich training programs so that scientists working in Arab world, let's say somebody working on their PhD, can spend part of their time at Ictp. And recently, we have been collaborating with the Arab Fund, and I'm very happy to report, and also Kuwait Foundation. They made quite substantial, we made a proposal to them to give additional funding to Ictp to make these mobility kind of programs broadly available for scientists in the Arab world. And we got some very good funding from both of them, and I'm very grateful to them. So I think with it, we would be very happy to collaborate with the Arab Physical Society. And perhaps, yeah, I think Arab Physical Society, I don't know. I mean, there are also funding issues, but I think it's worth thinking about together. I mean, some countries in the Arab world, funding is not the issue. It's oftentimes the, so I think Ictp does have a very important interest and role in the Arab world. As I said, two major foundations are collaborating with us. We have something like 10,000 scientists who have been to Ictp from the Arab world over the past so many years. So it's a large number, and we would like to continue to play that role.
Yeah, that's great. And looking ahead, what are your goals for Ictp, particularly in terms of its impact on the Arab region? And do you have any upcoming projects or initiatives that you are excited about?
Yeah, so, when I became the director, I asked myself this question, that is Salam's vision still valid today? I mean, do we really need Ictp? To that, my answer is yes, as I've told you, because I think there is a big need in the world. And I think it's almost impossible to create a structure like Ictp now. We should really preserve, it's really a treasure for the world, that we should preserve this very important scientific institution and try to expand its role. That's what I feel. But it's also true that it cannot be, we cannot just run on autopilot, and we have to think differently for the 21st century and not just mimic. There are different priorities, different challenges than what Salam was interested in. Now the science has changed also. The frontiers in science are no longer to look for the Higgs particle, right? That has been done. We are looking for different questions. There are different frontier questions that scientists are interested in. So both the scientific priorities have changed and the geopolitical situation has changed. One important change is that in many countries now, economic, like let's say the BRIC countries, India, Brazil, South Africa, China, funding is not really the issue, or many Arab countries. So Ictp can actually, and there are already very strong scientific communities existing in these parts of the world. So now I think the partnership can be more of an equal partnership than it used to be in the past. And the main goal would be to help make these international communities more internationally connected with each other. And I think that's where I see the role for Ictp, and that's what the kind of agreements we had with Arab Fund and Kuwait Foundation. But one program in this that I'm particularly interested about, and which I think is going to be a very important need, not only in the Arab world, but I think around the world, is that computing is really becoming extremely important. I mean, you have seen all these news about artificial intelligence, quantum computing, and ChatGPT, and self-driving cars. And currently, and this is becoming more and more important, not only, I mean, it is definitely has already become very important part of science in, let's say, climate modeling, or people when they do quantum material science. But even in more, or let's say, big data that you have to analyze at CERN or in the square kilometer array in cosmology, it's clear that computation is going to become fundamentally important in the next 10 years, much more than it used to be in the past. And I'm a kind of a pencil and paper physicist like Salam. But it's clear to me that the next generation, 10 years from now, unless we are able to make these resources, I mean, Ictp's fundamental mission is open science. And I think now it's clear that any notion of open science must include a notion of open access to computing, computational resources. And that's why we launched an international consortium for scientific computing. This is the idea that was approved by our Scientific Council of Ictp. And I have to say that in the last 3-4 years, we have been pushing for it. And we have had good success and we are on the right track. I would like it to proceed even further and farther. But we have now agreements with South Africa, Brazil. We are working on agreement with Brazil or with Indonesia or with corporations like IBM and other international agencies like SECAM in Switzerland, in Cineca. And these are supercomputing facilities, national supercomputing facilities around the world. And the goal is to create this consortium so that these computational resources become available more broadly. And this I regard as an important obligation for Ictp. And this requires substantial funding, but it also requires, I think, it's clear that it's important to collaborate and cooperate. That's why it is called a consortium. So I'm quite excited about this idea, and I hope that this becomes one of the very major pillars at Ictp in the next 10 years.
Okay, great. This is a related question, but it concerns Ictp itself. Many of my colleagues who visited Ictp in the past and now they would say that considering that the Ictp initially centered on fundamental physics, such as high energy physics, including cosmology and condensed matter physics, alongside mathematics. The recent expansion into applied sciences, such as earth sciences and medical physics, technology, data analysis, they think that this might dilute the impact of the Ictp and its original message of fostering fundamental science in developing countries. What are your thoughts on this?
Yeah, so I think I can understand where this thinking comes from, because I work on, as I said, on a field which is on quantum black holes and holography and string theory, which is not directly has a bearing on immediate societal problems. But I do believe that this is a very important aspect of science. And this is where Ictp has core competence. Ictp is strong. We have very good people working in these fields, those fields that you mentioned. So I don't think Ictp needs to move away from this core competence, and that's not the thinking. But as I mentioned, let's say even in these fields, like let's say suppose even if you're interested in fundamental questions, let's say the early universe, now the square kilometer array that will go online in South Africa, the data that will be coming in to analyze that data requires a huge amount of computing, which is little bit, you might say, is not it's not like the paper and pencil kind of physics, but it is important for addressing some fundamental problems. Similarly, so I don't think we need to choose one over the other. The way I look at it is that the Consortium for Scientific Computing will surely help fields like climate modeling, but in quantum computing, you need fundamental understanding about quantum information. And there are some very beautiful connections in my own research between quantum entanglement and space-time geometry and gravity. So there are, science sort of is connected in many different ways. And I don't see, and also some of these techniques, modern techniques, are being used in quite abstract topics, let's say in algebraic topology, or it's not as though computing is restricted only to high performance computing or modeling. For example, if you want to study several cases, which are very easy, suppose you have some conjecture and human beings can only test it up to, let's say, 40. But a computer can easily do it till 400. And if you found a counter example, then your conjecture can be eliminated. So some of these, in the same way that we used computing in the past to aid human thinking, I don't necessarily look at it as a it can be very complementary. So I think Ictp needs to do both. And I would not want to do one at the expense of the other. So I think my goal for the International Consortium for Scientific Computing would be to get additional funding for this initiative and not divert the funding from our core competence.
Yeah. And on the other side, many theorists in fundamental science in the Arab world and generally in developing third world countries do complain that their work doesn't find interest, let alone funding, and being accused of working in the luxury of science, while it's claimed that third world countries need only applied domains with direct implementations on the development of the country. So how do you think we can argue against these claims?
That's thanks, Rans. You have asked a very important question. It's a question that I actually myself wrestled with when I went back to India. That should I be working in this comfortable surroundings on problems related to black holes when the countries clearly there are great important development problems facing a country like India. I think it's very important that scientists acknowledge a certain gratitude about this to the society from which they receive this, because it's really a privilege to have this kind of freedom of thought in a country which is severely constrained for resources. And I can quite understand the challenges that policymakers have to face when you have to decide about funding in primary education, health, and clean water, which remain even today in a country like India priorities. So I think it would be, you would have to be really very closed and self-centered to say that, no, we need funding for fundamental science at the expense of all of this. But I think the other aspect of it, so I think this challenge has to be managed. But I am also firmly believe, and I'm quite convinced that a developing country absolutely must invest in fundamental science. I mean, and the reason is that science really is very interconnected, and there is no shortcut. You cannot just jump from not knowing even classical mechanics to building a quantum computer, because then you need somebody in your society, in your country, who is able to understand basic quantum mechanics and really has a feeling for it, and is able to train students who can use it for quantum engineering. So this we see actually. I mean, we had AI schools in Africa, and we get 200 applications, artificial intelligence, and only 10 of them have the sufficient background in basic statistics, mathematics, physics, to be able to really use it in an effective way, the artificial intelligence, if you want to implement some algorithms. So I think in this respect, I like this, when Emperor Ptolemy was trying to learn geometry from Euclid, Euclid tried to teach him, and then it was too complicated. So the Ptolemy asked him, can you simplify this? And then Euclid said that, sorry, Your Majesty, there is no royal road to geometry. And I also believe that there is no royal road to development and royal road to science, because you really have to create a broad scientific community within the country. It's also important for another very important reason. I mean, I think, and this is recognized in Indian Constitution, to promote scientific temper. It's very, you see around the world, the amount of the kind of grip, even in developed countries like the United States, the kind of opposition climate science faces, or let's say during COVID, the kind of opposition that modern, vaccination techniques faced. It's very important to be able to communicate to the public the importance of basic science. These are, what is science? And this is where I think people working in fundamental science can play a role in terms of this kind of developing this public awareness. And all this requires a kind of a more comprehensive approach to development, in which, of course, primary education and health would take the big chunk of the priorities. But I think ignoring fundamental science completely and thinking of only technology, in my opinion, is a very short-sighted policy. And actually that country will suffer. And I think Salam realized this very clearly, that the culture which will ignore high-level knowledge will in the end be left behind.
Okay. Professor Dabalkar, considering ICTP establishment of various institutes globally in the world, such as the ICTP South American Institute for Fundamental Research in Sao Paulo, the East African Institute of Fundamental Research in Rwanda, ICTP Asia Pacific in China, and the Mesoamerican Institute for Sciences in Mexico, we wonder why there hasn't been a similar initiative in Arab countries. You just talked that it is possible to arrange to collaborate between to do collaboration between ICTP and Arab Physical Society. So can we envisage a sort of memorandum of understanding between the two institutions collaborating on joint activities?
Yeah, I can tell you something that we have learned from these experiments, I would say. I think this idea, the fundamental idea of having a partner institute, is a very good one, in that you do locally what ICTP does globally. So if you want to, for Latin American countries, I think I was recently in Brazil just 2 weeks ago to celebrate the 12th anniversary of the ICTP Cipher, the South American Institute for Fundamental Research. And it happens that 2024 is the 60th anniversary of ICTP. It was a very nice occasion, and I was in Sao Paulo for that reason. And that center has flourished very well. There is quite strong funding from the local government, strong support from the university. All the high officials from the university and the funding agencies were present. And it has been, I would say, really a very good success. So if you want to repeat that success, you cannot go into it just by signing a memorandum of understanding. What I realize is that there has to be a really more serious commitment and understanding, a scientific case, and a commitment from the local authorities, the government, about what sort of funding will be given to this effort, what sort of resources will be given, where the location will be. It should really be thoroughly researched. I mean, we can have an MOU for this kind of mobility that I described to you, organizing conferences, symposia together, having opportunities for Arab scientists to come to. So this can begin. This can be the beginning to develop this kind of nucleus of people who can then develop some kind of a core group of people who can try to have an ICTP partner institute in Arab world. I think this certainly is a possibility. But and it could be very exciting actually to do it in the Arab world. But one should not start by a memorandum of understanding. I think one should start with a really solid, well thought out, complete proposal. What will be the funding arrangements for the next 10 years? Which country is willing to, or which foundation is willing to commit to that? Otherwise, it becomes it's a good initiative which actually will not deliver in the long run. So I think I would say that I would be very supportive if there is if somebody in the Arab Physical Society, because as I said, some Arab countries would be willing to make the funds available, and ICTP would be willing to make its expertise and international prestige and its international role available. But there has to be this kind of a real understanding. Because if, for example, it puts our resources are also limited. All said and done, ICTP actually, for its size, has a huge impact in the world. But just to tell you that to create a center three of our faculty members have to be constantly engaged. Just in terms of our time, also, actually, there is a commitment. Then who are the people there? So I really think that there could be a very good opportunity in the Arab world if it is thought through carefully and correctly and seriously. And the ICTP would be is very open to such a possibility. And as I told you, we are collaborating with the Arab Fund or with Kuwait Foundation. If a coherent proposal can be developed, with some real understanding of what are the challenges, what is the requirement, then I think it's a great idea. I would be willing to pursue this.
Yeah, that's really great. Yeah. And so, Professor, it appears that that the participation of Arab individuals in the ICTP activities, such as ICTP diploma programs, summer schools, and workshops, and associateships, especially senior ones, has decreased compared to the past. So, could you provide an explanation for this trend, and do you have any suggestions for overcoming it?
Well, is this really true? Okay, I'm not aware of the statistics, but maybe you have looked into the statistics. Is this true?
Yeah.
Yeah, it is true. I see. No, so as I told you, my goal is exactly the reason. I was very happy that the new Director General of Arab Fund, he immediately welcomed me and he was very keen. Also, likewise, the Director General of Kuwait Foundation, they were both of them very keen to collaborate with ICTP. And they came forward with a nice project and they immediately supported it, funded it. So I expect that with that additional funding, the participation from the Arab world will surely increase. And there is actually another point I want to make is that, Nidal, you are from Syria and Rand, you are from Palestine. ICTP, as I said, we have many students, for example, from Gaza or from West Bank. We have a number of people from Afghanistan and from Iran. I think ICTP also considered it an important role to protect scientists who are in a difficult, let's say, scientists who are in exile sometimes, or scientists in a politically or social situation of social upheaval or political upheavals. So scientists in exile is something that ICTP has several scientists from many of these regions in the world where either there's a war going on, and once again, that requires funding. And we can do it up to a point within our resources. Maybe we can fund 5 scientists, but we cannot fund 10 scientists. So I think, for example, the Royal Society for Science of Jordan, Princess Sumaya is the president. She told me that the RSS has a program for supporting scientists in this kind of difficult situations. And it would be good, for example, if the Arab Physical Society could make it possible. ICTP can collaborate also on that front to support scientists from the Arab world who might be in politically difficult situations.
So we still have 2 questions. I would suggest, Rand, you go now for this question forwarded to us from some junior colleagues, and then I will end by the final question.
Okay.
Yeah,
Rand? Yeah,
that's
you
great.
go, no?
Can you hear me? Hello? Yeah.
Yes.
Can you hear me? Yeah. Yeah. So another question forwarded to you from some colleagues. How do you see physics after 10 years? And what would be the most active field in the domain of science? And expected effects of artificial intelligence revolution that we witness now on the development of physics. Many students doubt that the benefit of working fundamental science and see that artificial intelligence would solve the physics problems. So any thoughts in this regard?
No. So as I said, we already discussed part of this answer.
Yeah.
I think there are many exciting frontiers of science. I would love to know, for example, questions like how is Einstein general relativity made coherent with, can be unified with quantum mechanics? It's a question. It's a very important question, and there are actually very clear, concrete achievements that have happened. For example, holography is a very beautiful and important concept. Duality is another such concept which has come up in our studies of quantum field theories and string theory, that you discover that a pure quantum field theory, in which nothing falls. Quantum field theory deals with charged particles and light, for example. It has nothing to do with gravity. But it turns out the holographic correspondence made us realize that certain kinds of quantum field theory actually have an equivalent description in terms of gravity. This is a holographic correspondence. And same thing in duality also, there are different descriptions of the same phenomena. So there are some very deep questions and very exciting new ideas which are far from fully understood. And I think there is a great potential for all kinds of very interesting questions. What is the structure of the early universe? New cosmological observations are going to become available. We don't understand the nature of dark energy, or we don't understand the nature of dark matter. So I don't think, so it's clear that it's going to be very, I think, another 100 years. Then we have gravitational waves, which are giving us a completely new view on physics. I think all these fundamental questions, and of course the progress in mathematics and condensed matter physics has wonderful developments in quantum information theory, together with some of the really serious existential challenges that we face in climate science. I mean, those are actually more not questions of science, but more questions of politics. But you need to understand the science properly to understand what are the effects of the climate crisis that is really coming. So I think science and evidence-based science, both at the fundamental end and at the more practical end, has a very important role to play in the coming years. And artificial intelligence will certainly expedite the process. I mean, we can do certain questions, certain extrapolations much more easily. So it's going to revolutionize the way we do science for sure. And that's why we started this idea of an international consortium for scientific computing. But I look at AI as a kind of a tool rather than, I'm not yet convinced that, I don't think, I mean, if you just observe an apple falling many times and you feed that data to train an artificial intelligence thing, I don't think you're going to discover general theory of relativity. Or or more okay, this was slightly facetious remark, but I would say, for example, you could have discovered the ideal gas law. PV is equal to pressure times volume is proportional to the temperature. This could have been discovered by artificial intelligence by looking at the experiments that were done. But what really led to fundamental advance in science was Maxwell and Boltzmann's idea of a statistical mechanics. And maybe the gas in this room is made up of little atoms. And this kind of a reductionist view to really reduce pressure, temperature to motions of atoms was a very key insight. And I don't think that coming out of just doing curve fitting. This requires, I think, human creativity. But you could discover new relations which were more difficult to see, or to go from Kepler's law to Newtonian mechanics. That requires a kind of a human creativity, which I think will be important. So I think artificial intelligence will certainly revolutionize our thinking. But this kind of science that we have been doing, where we really develop a deep underlying structure, really a layer of reality, explaining in few equations, the whole, whole complexity of phenomena. I think that is not going to go away, and that will remain, I would say.
Okay, great. So as a final message, Professor, what advice would you provide to young Arab students and researchers who want to pursue a career in theoretical physics? Based on your experience, what actions should people take to reach their full potential and succeed in this field? How can we single out honest scientists who work diligently amidst faked ones who, unfortunately, can sometimes blossom in the absence of decent scientific infrastructure, as it is the case in some regions of the Arab world?
Yes, I mean, one thing is sure, that if young students who are passionate about science should pursue it, it's important that they get access to good books, it's very important, and good colleagues. What really mattered for me, I remember when I was a beginning student, I had an excellent colleague who later on he went to Caltech, I went to Princeton for my studies, but we could really, those colleagues were more important. And then we had a couple of very good books, immediately we read Feynman's lectures, and then there was a wonderful book of Cohen Tanuji on quantum mechanics. I mean, we just taught ourselves from those books, and that you have to experience. And I agree that not all places offer that possibility sometimes. And maybe the initiatives of the Arab Physical Society that you do locally and what we can do at Ictp can be a way to make these opportunities available. I mean, I think that's precisely the mission of Ictp, that we would not want the next Ramanujan to be at the mercy of the forces, of social forces. That's one point. The second point is actually, Arab science had a very major role to play in the history of science. And I think this fact is sometimes, I would like to actually emphasize this fact, that Salam actually later in his life became more aware of this. But I think there is no question that the history of science was written from a very Eurocentric point of view. And sometimes that gives a feeling as though no great advances have come from the Arab world or from the Indian. But if you look at the actual history, serious history, I'm not talking about just chauvinism to say that, okay, in the Vedic times we had everything in India. I don't mean it like that. But if you look at a serious history in the Arab world, for example, Hassan ibn al-Haytham, around 1000, he wrote this famous book, Kitab al-Manazir, on optics, which really laid the foundation of the scientific method. And he understood the many important properties of optics and vision. And he even, I think, understood the least time principle, which is later called Fermat's principle. So as the light travels in various properties of light that we take it for granted, he deduced it by experiment. So this experimental method actually started in the Arab world. Or if you look at Al-Khwarizmi, this is earlier, I think around 750 or 800. So he was in Baghdad, an astronomer, a very polymath, a mathematician. So he wrote this famous book, I think, Al-Kitab Al-Mukhtasar fi Hisab Al-Jabr wal-Muqabla.
Oh, your Arabic, your pronunciation is very good. Yeah.
So Al-Jabr wal-Muqabla means to, that's where the word algebra comes from. Algebra becomes algebra when it went to the. So you are basically the idea that we learn in school. I mean, when I teach my son this idea that you balance things on the equation and manipulate algebraic equations, it's a very fundamental contribution to algebra that started in the Arab world. So there is a historical tradition in this region which has been lost because of various reasons, cultural reasons. Sometimes in the case of India, it was colonialism. So one needs to overcome that. Or also in India, for example, many developments like calculus, some of the very fundamental developments on infinite series were discovered almost 200 years before Newton and Leibniz by Madhvacharya's school in Kerala. So I think it's also important for Arab students and Indian students to be aware of this historical tradition, not because you want to say that, okay, therefore, etc., or not to ignore the great advances that were made in the Renaissance or in Europe, but to have the confidence that science really is a common heritage and common creation of all humankind. And it's not a privilege of some white male in the sitting somewhere in a European country. I think I mean, these were all really great scientists. I mean, I mentioned Ibn al-Haytham, al-Khwarizmi. From India, I can name Brahmagupta. These were really very high class mathematicians on the level of Euler or Newton. And they are not sufficiently known to even people living in the students in that country. And that's part of it has to do with the bit of the colonial legacy of the last 500 years. And I think that, so having this awareness and confidence is also important in restoring the prominence of science in the Arab society as well as in societies like India.
Okay. In fact, even in our magazine, we intend not only to have articles on simple science, but also about the history of science and the contribution of the of many nations in the development of science. Let me thank you a lot, Professor Rand, and I really are very grateful that you allocated to us this wonderful interview, for giving us this opportunity to interview you. And I just say thanks a lot,
Thank you
Rand.
very much.
We get the pleasure to meet you, and we really thank you so much for giving us this chance to interview you.
Thank you. Thank you. It was a pleasure to talk to you, both of you.
Okay, so you can stop the recording, Rand.